Namaste everyone. Earlier we have studied about how X-rays were produced by Bremsstrahlung and characteristic radiation in the X-ray tube. It then went and hit the patient, and then we studied the interaction, photoelectric effect, Compton effect. Now we'll study what happens after it has hit the patient and it is transmitted down. This will be captured by the image receptors on the plate. Nowadays we use computed radiography, that is CR, and digital radiography for capturing this image. Therefore today we'll study about CR, that is computer radiography, and DR, that is digital radiography. As you can see from the image, we can see the CR plate, the scanner. On the right side we can see an individual putting the CR plate in the scanner. Further we'll study how this principle works. Now let us see the mechanism. The X-rays from the patient has fallen down. It has hit the image plate, the CR image plate. The image plate of the CR is made up of europium bromide, given by the formula Eu2+. What will happen when the radiation will strike this europium bromide? Eu2+ will get oxidized. Means what? Eu2+ will become Eu3+ and give out electron. This electron is now emitted. What happens? Electron will move from the valence band to the conduction band and will get trapped into the forbidden band. Now what will happen? The amount of electron which was emitted will be directly proportional to the X-ray that has fallen on the CR plate. More the X-ray will fall on the CR plate, more the amount of electron will be emitted. This will form the latent image. Now what will happen? When we will give red light to this latent image, the electron will reach to the conduction band and then the valence band. Therefore there will be release of light. This light will be in the form of blue-green light. Like what happened? Eu3+ plus electron was there, red light was given, it again converted back to Eu2+ and blue-green light is given. This light goes through the tube to the photomultiplier tube, signal is produced and therefore image is formed. This image is CR image. Now what will happen? Even after giving red light, all the electrons from the forbidden band will not be left. Some of them will be trapped. Therefore we'll give white light so that all trapped electrons are empty. The CR image is cleared and it can be used for second imaging. Therefore now the CR plate is ready to shoot for another image. Let's see the whole process once again. Suppose the patient will go for chest X-ray. From the X-ray tube, X-rays is produced. It goes and hit the chest of the patient. Some of them will be absorbed, like bone will absorb all and will not allow the X-ray to pass, whereas through the lung the X-ray will pass through the patient and goes and hit the CR plate. Now the instructor will remove the CR plate and will keep in the CR sensor. What happens in the CR sensor? The CR plate, it is made up of europium bromide. As soon as the X-rays which was passed through the patient and get hit the CR plate, the europium bromide, the Eu2+, will get oxidized. What will it form? It will form Eu3+ plus electron. The amount of electron emitted will be directly proportional to the X-ray it has incident. If it has not in that region, if it has not gone and hit that region, will not show electron emission, whereas wherever on the plate it has hit, it will show electron emission. What happens to the electron? it will move from the valence band to the conduction band and get trapped into the forbidden band. Now in that sensor, in that scanner, latent image is formed in the CR plate and the scanner. Now the scanner will give red light. What will happen? EU3 plus electron will get again converted to EU2 plus blue green light. From conduction band, electrons will then fall to the valence band and emission of light blue green. This will go through the photomultiplier tube, signal and a CR image. Therefore, what happened is the CR plate was removed from the edge, it was put in the scanner, red light was given in, and the whole procedure from wherever X-rays were attached, it will show the image. Now all electrons from that forbidden area will not be eliminated by the red light. Therefore, we give white light and vanish all this remaining any electron will be present. Therefore, now the CR plate will be ready for shooting another X-rays like chest X-ray. Now let's study DR or digital radiography. In DR, the scanner, everything is directly attached to the table. Means if a patient is going for chest X-ray, it will fall on the patient chest, and that through the chest it will go to the table and hit the image or a DR plate which is directly installed under the table, and all scanning everything will happen and directly image will be produced. Therefore, in CR there is a CR plate which we have to remove and then put in the scanner, whereas in digital radiography or the direct radiography, we directly form image. Means we shoot, it goes to the patient, hits the image on the DR, and directly image is being formed. Now DR, it can have two types, direct DR or the indirect DR. Indirect DR, it means that X-ray is converted to light and then the electrical signal, whereas in directly X-ray is converted to electrical signal. Therefore, difference is the light in indirect. Now let's study the principle of DR. First, indirect DR. What happens? X-ray will then interact with the phosphor present in the DR plate. It will emit light. Light will go and hit the silicon photodiode. It will produce electrical signal, that is electron, and through electron which we can get flat panel and get the analog to a digital image. What happens in direct DR? Direct DR, X-ray will directly hit the selenium photoconductor which will directly produce electronic signal or electron, flat panel, and then an analog to a digital converter. This DR is directly placed inside the table. Therefore, when when the X-rays will hit the DR plate, either through indirect DR or direct DR, directly image will be formed. This is DR.